A happy day to all. I am K. Thavamani, Assistant Professor of Statistics, Department of Mathematics, KSR College of Arts and Science for Women. In this video, we discuss about industrial statistics. In industrial statistics, we have the probability distribution. A probability distribution describes how the probabilities are assigned to possible outcome of a random variable. It provides a complete provide of how likely different values are occur in a random experiment. Probability distribution helps us to model real-world situations such as the number of students arriving in a class, the lifetime of a machine part, the mark of students, or the outcome of repeated trial. They allow us to predict, analyze, and understand randomness in a mathematical and systematical way. Probability distribution can be classified into two ways. First one is discrete distribution, the second is continuous distribution. In discrete distribution, where the random variable takes countable values, example, in this category we have the binomial, Poisson and geometric distribution. In continuous distribution, we have normal, exponential, uniform distribution. In continuous distribution, where the random variable take infinitely many values in an interval. Each distribution has specific properties such as a mean, variance, and a shape with help in statistical modeling and decision making. This probability distribution forms the foundation for statistical inference, data science, engineering, application, and scientific research. Probability density function. A probability density function is a function that describes the relative likelihood of a continuous random variable taking a particular value. Instead of giving probability for exact values, the probability distribution density function gives the probability of the variable falling within an interval. For continuous random variable x with the probability density function f of x, for f of x greater than or equal to 0 for all x. The second one is the total area under the curve is 1. The probability that x lies in the interval a to b is given by integral of a to b f of x dx. Multivariate distribution. A multivariate distribution describes the probability behavior of two or more random variables considered together. If specified how the variables are jointly distributed and how they may be related or dependent on each other. For random variable x1, x2, xn, the multivariate distribution provides joint probability function and joint probability density function. A valid multivariate distribution must satisfy the condition. The first one is non-negativity, then the total probability equal to 1. Multivariate distribution allows us to study relationship, correlation, dependencies and interaction among multiple random variables. Marginal distribution. A marginal distribution describes the probability distribution of one variable from multivariate distribution, ignoring the other. It is obtained by summing and integrating the joint distribution over the other variables. For discrete variable, if x and y the random variable, then the joint probability mass function p of x comma y is probability of x equal to sum of p of x comma y. For continuous random variable, if x and y continuous random variable, probability density function is integral of f of x comma y. Mathematical expectation. Mathematical expectation, also known as the expected value, is a fundamental concept in probability theory that represents the average or mean values of a random variable over a large number of repetitions of an experiment. It gives a measure of the central tendency of the distribution of the random variable. For a random variable x, the expectation provides the value we anticipate on average, even though individual outcome may vary. It serves as the bridge between probability and statistical analysis, helping in decision making, forecasting, risk analysis, and modeling real world uncertainties. Thank you.